All right, we're going to go through 2 free response questions today. We're going to work this like a warm-up. So you are going to eventually, when I'm done here, hit pause. You're going to try A through D to the best of your ability. Then you'll hit play and I'll talk through the solution. Okay. Now each free response question you get about 10 minutes. So set yourself a timer and see what you can do in 10 minutes. Some of them are a little more like 8, but if you set it at 10 minutes, that should be about the correct amount of time. Okay. So again, go ahead and pause the video when I'm done here. Try A through D, excuse me, and then hit play, and I will talk through everything. When you are doing your free response question, make sure you show your work. You know, we'll talk about AP test, and there'll be boxes for you to do A and boxes for you to do B. But for our final, just make sure you hit each part and you label which part it is, because you'll be doing it on a piece of paper versus a paper that we give you. Okay. So for this one in A, it wants you to show that dy dx equals this. And so I noticed that I am starting with that implicit. So I need to go through, and again, I'm giving you the answer. This question gives you the answer. I want to see all the work that leads to that. So let's start with that y squared. So I power out, power down. Then I remember that dy is not, or it is my dependent variable, and it's dependent on x. So the derivative of y is dy dx. The derivative of 2 is 0. I'm going to put that there. It's just a placeholder for this step, but then that will go. And then these two should be a product rule. So the derivative of the first, which is x, is 1 times the second, plus the first times the derivative of the second, which is dy dx. Now I'm going to subtract that over. So 2y dy dx minus x dy dx. Now I'm just going to have this equal y. Okay, I can factor out dy dx. 2y minus x equals y. And then divide over, actually I'll finish here. So then dy dx equals y over that, and then you see that that matches perfectly with A. Okay. Now B wants us to find all the points where the where the curve has a slope of a half. Well, slope is what I just found, that's dy dx. So what I'm going to be solving is where y over 2y minus x equals 1/2. Okay, so solving, I would cross multiply. So 2y equals 2y minus x. We'll subtract 2y, so 0 equals negative x. So it's wherever x equals 0. Now notice it wants all the points. I just found the x value. So to find the y value, you have to plug back into your original. My original was that y squared piece up there. So I would have y squared equals 2 plus, well then 0 because x was 0. So when I square root, I get y equals plus or minus the square root of 2. That's why it's plural. And so my points are 0 square root of 2 and 0 negative square root of 2 for B. C then wants me to show that there are no points where you have a horizontal tangent line. Horizontal tangent line means that your slope, so if I draw one plus my slope, it's 0. So again, I'm going to set my derivative, 2y minus x to 0. Now when I cross multiply, I can put that over 1. So I would have y equals 0. Okay. Now that doesn't mean that there's none, but when I put that back into my original, I have 0 squared equals 2 plus 0. So I have 0 equals 2, which is a false statement, like 0 does not equal 2. So since, I'll say since 0 does not equal 2, there are no horizontal tangent lines. And you don't have to write it nice, I'm just trying to do it at home here. All right, D, I'm going to slide down a little bit. Can I fit it in here? Yeah. Okay. So D wants us to, now I read carefully, and it says let x and y be functions of time. So time is my new, as a function of, means this is my independent variable. And then here's that exact same equation. It says let t time be 5, let the value of y is 3. I'm going to start kind of writing some of this down. So y is 3 dy dt, which that should be kind of a, oh, look at that. Kind of show us what we're doing here because of that notation. So I want to find dx dt, so I'll say equals question mark. I'm going to circle it because that's what I'm trying to do. And again, at time 5. So 5 is like your moment. Now, notation-wise, there's a lot of things to help you figure out what kind of problem this really is. It talks about t being your independent variable. You have x, you've got y, you have a dy dt. This is a related rates problem. Okay, so I'm actually going to go back to this y squared equals 2 plus xy, and I need to retake the derivative, but now t is my independent variable. So when I take the derivative, I'm going to switch colors so things don't go here. The derivative of y squared, it would be 2y, but now it would be dy dt instead of dy dx. The derivative of 2 is still 0. Now, when I take this product rule, each derivative is going to be in terms of time. So your derivative of x is dx dt now, and then with a y. And then x derivative of y is dy dt. Okay, I'm going to go through and plug in what I have and kind of search for what I'm missing. So I know my y is 3. I'm going to slide down here just to make it easier. So I'd have 2 times 3 dy dx, or I'm sorry, dy dt is 6. I'm looking for dx dt, so that's okay to be there. Y we said was 3. I don't know x, so I'm going to come back to that, and then 6 here. So I have to think, how do I know x? So, because I'm given the time, but I need x. Well, I can come back up here, and I can put 3, so I'd have 3 squared equals 2 plus 3x. So subtract 2, 7 equals 3x, so x is 7/3. 7/3 is what will go there. Okay, so last step is just to solve for dx dt, because that's what it was asking for. This term, just being strategic here, I can do 6 divided by 3 is 2, so this is really 14. So I would have 36 minus that 14 divided by 3 equals dx dt for that. Okay, now without a calculator, you just leave it. If you want to simplify, yes, 22/3, but without a calculator, you can leave it just like that. No problems there. All right, here's our second one. You are going to use a calculator for sure on this problem. Just make sure that when you're using your calculator, you are showing your calculus work and calculus steps. So if you're going to set something equal to 0, you have to write equal 0 on your paper. Then yes, you can go use your calculator to solve it, but you have to show those steps along the way. So go ahead, you're going to take a 10-minute timer, pause the video, try A through D, and when you are done, or when the 10 minutes is up, either one, hit play and see how it's done. So I've got this function f. I am trying to find the local max and local min. And again, like I mentioned earlier, you have to use calculus. You can't just graph f and find the highest, or the change in direction, the local max, local min. What you do need is that t-chart idea, that it should be where your derivative equals 0. Whoops, derivative. So first things first, I need what is my derivative. So f prime would be, so 3, when I power out, would be 3 over 6, so a half x squared. Derivative of cosine is negative sine of x. Derivative of 1 is 0. Okay. So first step is you write your derivative. Second step is you set it equal to 0. And yes, you have to write that. Okay, now you can grab your calculator and you can graph, and you end up with something like this. And you get 2 zeros. You get x equals 0 and x equals, where on my paper, there it is, 1.4044. You must have 3 decimals, so I just wrote 4 so you can see if you round or truncate. Now, let's tell it which one. So I know that 0 is going from positive to negative, so this is my local max. And if it were to ask y, which it doesn't, but just to be thorough, I'm going to write it here for you. So it's a local max because f prime goes from positive to negative through 0. Okay. So then this one is our local min. And for a similar reason, that because f prime goes from negative to positive through 0. Okay. All right. When I get done, I was just rereading the question to make sure I got everything on there, but I did. So B, find the linear approximation of f at pi. So linear approximation. I want to estimate or approximate something with a line. That means tangent line. Now it's not as direct as saying write the tangent line, but that's what another way to break down those two words. So I want a tangent line at x equals pi. Okay, so all tangent lines, I need a point and I need a slope. I have the x value, so let's start by finding the y value. So the y value would be from putting pi into f. Now I can write, like on your work, you can just write that because they know you have a calculator. And so that comes out as 5.1677. Okay, but you show where you're getting that, and this is doing that. Okay, then the next thing you need is you need the slope at pi, which would be f prime at pi. Now I already found f prime, so I don't need to show that work again, but I do need to show that I'm going to put pi into f prime, and it comes out to be 4.9348. That's what I got. Okay, so my point then is pi, that 5 number. Here's my slope, so I'm going to write my line. Y equals 4.9348 x minus pi, and then plus 5.1677 for my y value. C then wants us to use what we got in B to approximate the value of f of 3. Now, even if you got B wrong, you can still use your wrong, just write a tangent line and use it and plug 3 in, because that at least shows that you know what that part is. And you don't want to lose the points for this step, which is super easy, just putting 3 in there, because you didn't know how to do B. So at the end of the day, if that happens, make something up for B. You lose those points, but you can still get C's point there. And let's see, I got 4.46896, and yes, I'm writing too many decimals, but you know, you can round or truncate after that 8 because you guys need 3 decimals. All right, D then, is your approximation in part C an over and under estimate, and justify your answer. Okay, so I want to know over or under. So conceptually, the difference is if you are writing a tangent line here versus a tangent line here, these are an over because you're over it, and these are an under. And your difference is concavity. If you are concave down, it's an over. If you are concave up, it's an under estimation. So really you want to know concavity to do this question. So if I go back to f prime, its graph looked like this. Okay, so here I am at 3. Sorry, I'll just find my value again. So at x equals 3, so f prime is increasing at x equals 3, so f is concave. Sorry, it doesn't write well on the bottom here. Let me slide up. This says concave. Let's try again. There we go. So f is concave up, which means this is an under estimation. Okay. Every explanation uses that calculus, something with calculus. You can't just say, well, on there when I draw, you know, on F when I draw this, it looks that doesn't show you know anything about calculus. So make sure justifications, rationales, you know, showing work up here. You know, yes, we did most of that on our calculator, but you still showed that you know that local maxes happen where derivatives equal 0, and so you had to show both of those things. So on your final exam on the written part, make sure you show us your calculus knowledge.